Again, you're looking at questions here, trying to determine which one might be the easiest to do. 3 is a bit wordy. 1 is asking about tangent lines. 2 is a question about a quadratic equation. 3 is a root equation. And 5 is a log. I'm going to try to do 5 first, all right? So I'm going to write this down for you, number 5. And the way I'm going to do that, I'll write x equals log. This is base 10, 81. I want to point out just it's one possible simplification. This is log base 10. And 81 would be 3 to the 4th power. And that means 4 log base 10 of 3 would equal x. All right, let's do the other one, y. And what's y going to be equal to? Log base 10 of 25. And that same thing as log base 10 of 5 squared. And that same thing is 2. I'm just writing down possibilities. Log base 10 of 5, and that equals y. Now, their question is this, though. Their question is, something about the log base 10 of 6. Well, the way I'd write that down is probably write it in terms of 2 terms. So log base 10 of 2 times 3. That's 6, right? Not much else I can do about that. And this would be log base 10 plus, I'm sorry, I forgot to put the number down. Let me get my eraser out. It happens sometimes, you forget to write the number down. So log base 10 of 2 plus log base 10 of 3. I guess I'll put parentheses on these things over here just to make sure you're clear about the arguments. And I'm going to put this here, not there. So I'm going to read this here, and I think I'm getting close to an answer, but not there yet. Log base 10 of 6. And do I see, I see this. And what's that going to be equal to in terms of x's? That would be, because that's my goal, by the way. That would be log base 10, 3 would be x over 4. And now I got to figure out how to get this guy over here. And the way I would look at that is the only thing I really do know is 5. And so I'm going to write this over here. I'm going to write log base 10 of 10, which I know to be 1, by the way, is also equal to, so 1 is also equal to log base 10 of 2 plus log base 10 of 5. And let me write this down. So 1 equals log base 10 of 2. And log base 10 of 5, I got that right over here, is just y over 2. So let's write that down. So it's going to be, let's see, that's going to be plus 1, right, minus y over 2. All right, where ax plus by plus c, where a, b, and c are rational numbers. So let's see what I got over here. I got to write in that order now, right? So it's 1/4 x minus 1/2 of a y. Again, I'm writing it down the order they want, plus the c, which is 1. So I know a is 1/4, b is minus 1/2, and the c is equal to 1. What's their question, though? Their question is, what's a plus b plus c? Let's write that down. A plus b plus c. That's going to be 1/4 plus 1/2. I'm sorry, not 1/2, it's minus 1/2. I just looked at that. Let me get my eraser out. Minus 1/2 plus 1. So that's going to be 1/4 plus 1/2. Well, that's not so bad. That's just 3/4. All right? Okay, let's take a look at the key and see what they got over there. This is 5, right? 3/4. All right, feeling good about that. So let's go back up here. I know I'm scrolling through this pretty quickly. We just did number 5. I'm going to get my eraser out. And I'm going to say that wasn't bad because I was able to do it. Maybe I should say it wasn't bad because I was able to do it. I want to point out, even though at certain days I'm able to do things, other days I'm not able to do things. So I'm going to look at the other questions, and I'm going to look at number 1 now. And number 1, just looking at it, they got, for what real numbers m is the graph. Well, I'm looking at this guy over here, and I hope you realize that you're looking at an object you're probably familiar with. And this object over here is a circle. That's an equation of a circle. And this guy over here is just an equation of a line. So what I'd like to do is I'd like to just, rewrite the circle equation for you. And the way I do that, the way you're taught in just basic algebra, is to rewrite it so you got a center and a radius to it. Let me put this down for you. So what's the equation going to look like? It's going to look like x squared, let's see, minus 4x plus y squared. Hoping this works out nicely, by the way. If not, I'll abandon ship and go to something else. And let's see what I got over there. That would equal m. I don't know what m is, by the way, minus 13. And then I'm going to complete the square. Half of minus 4 is minus 2 squared plus 4. Add 4 to both sides. And half of minus 6 is minus 3, and square that, you get plus 9. Plus 9. So I get something pretty simple. I get x minus 2 squared equals, I'm sorry, not equals. That's another crazy thing, huh? It's plus the perfect square, y minus 3 squared. And if you simplify the right-hand side, 9 and 4 is 13, and 13 minus 13 is 0, so m. So this is going to be a circle. Center, I'll write this over here for you. 2, 3, and a radius equal to root of m. All right? So, what real number m? Let's take a look now. So what real number m is tangent? Well, you know what? This thing's just a line. So all I got to do is figure out that guy's slope. And this guy's slope over here, let me write this down for you. Y equals, that would be minus x plus 5 root m. I'm sorry. I made a mistake there. I apologize. I didn't copyright. It's plus 5 plus root 2m. And the slope of this line over here, slope, I'm not going to use the letter m, by the way. The slope of this line is minus 1. So I got troubles now. My troubles is, I think what they want to know is that, what real number m is the graph, blah, 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 tangent to that graph. Well, now I got a slope problem. And there's many ways to do it. I'm going to use calculus to do it, though. And what I'm going to do over here is, let me show you what I'm going to do. I'm going to differentiate the circle. And what do you get? I'll write this down for you. I'll be careful about it. It's going to be 2x minus 2. Again, I'm differentiating this to the first power. And derivative of the inside is 1, dx dx. I'm going to put that down. Plus 2 y minus 3 to the first power. But the derivative of the inside is going to be dy dx. Put this over here. And that equals 0. All right? Now, what do I know about the dy dx? It's got to be minus 1. So where does that occur? Let me write this down now. So 2x minus 2 plus 2 y minus 3 times minus 1 is equal to 0. Well, I'm going to continue to move forward in this over here, including if it's a dead end. But I get something like this over here. Right? That's not so bad. I'll divide by 2, and you get x minus 2 is equal to y minus 3. I think I'm doing okay, right? And let's see what you get over there. I'm going to say x is equal to, let's be very careful now. X is equal to y minus 1. But I also could say y is equal to x plus 1, right? Now, I'm not saying that answers my question, but I got to go back and look at it again for what real numbers m. I'm looking for that m again, is the graph, blah, 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 tangent to the graph of this over here. Well, they got to share the point together. So I guess what I could do is, I guess I could plug in, right? And let's see if we can do that and see what we end up over here. So let's take a look here. And I'm going to wonder where I'm going to plug that in. And I don't know. Let's see where we could plug that in to make it easy to figure out what M is. There's a variety of places I could plug it in, right? I could plug it in here. I could plug it in here. Let me just highlight these for you. This is given information. And now I find these X and Y's. And let me just take a look at it and see if I could figure this out. And I'm going to write that down for you. Let's take a look here. Let me just write these down below, okay? Y minus X, Y plus X is equal to 5 plus root 2m. Is that one of the equations they gave me? Yeah. Well, you know what? Let this plug in. All right, let's see what happens. So I'm going to plug in y. So it's x plus 1 plus x equals 5 plus root 2m. Again, I'm using this up here. So let's see, x plus 1, that's what y is, right? So you get 2x equals, let's see, take 1 from that, 4 plus root 2m. Now, it's not giving me m, but I got a form for x in terms of m now. That's going to be 4 plus root 2m over 2. But it still doesn't tell me what m is. All right, let me see if I can do this equation again, but I'm going to use, let's see, I use the y. Now I'm going to use the x. So it's going to be y plus, and again, I'm using this. Let's see what you get. So y plus, what's x? It's y minus 1 equals 5 plus root 2m. Let me keep going. You get 2y. I'll add 1 to both sides. That gives me 6 plus root 2m. Again, it still doesn't tell me what m is, but now at least I know what y and x are in terms of m. This is going to be 6 plus root 2m over 2. Now I'm going to take this. All right, I got these now. And I'm going to plug it into my circle equation. And before I do that, I want to just write these a little differently. I'm going to write this as 2 plus root 2m over 2. There's a reason for this, because I notice when I look at my circle equation, I'm seeing those numbers. 3 plus root 2m over 2. All right, so x is, I'm going to plug it in here now. And what do you get? Well, I'm taking this, which is x, and plug it into that x minus 2. So I would just get the root of 2m over 2 squared plus, let's be careful about this. It's 3 plus the root of 2m over 2, and that's subtract 3, so you can get the root of 2m over 2. Again, I want to emphasize that m's got to be a positive number. I'm seeing that here, and I'm seeing that over here, by the way. And what's that going to equal? It's going to equal m. Well, now I got an equation. I'm sorry, I forgot to put the square there. In terms of m now, at least. I can figure out what m is, hopefully. And what are you going to get over here? Let's see. You can get 2m over 4 plus 2m over 4 is equal to m. Wow. What does that give me? That gives me m is equal to m. So this is going to be true. This is true. It's an identity. It's true for all m greater than 0. Otherwise, it wouldn't have a circle, by the way. All right? Actually, you know what? I can include the 0. All right, I just can't include negative numbers because it does say real number m. And if it's a real number m, the root of 2m, if it were negative, would be a complex number. Then I'll put a restriction on that. But anyway, I'll just say for all, it's true for all m greater than or equal to 0. Let's take a look at our answer key over here. And let's see what they wrote down over here. This is then true for all m greater than 0. They did say that. You could put 0 down too if you want, though. Illustrate several incidents that help clarify. All right, let me just take a look at that. Yeah, I'm seeing that. But if m is 0, you don't have a circle. So let me just, you know what? Then you'd have a point. And you wouldn't have a tangent line to a point. So yeah, m's got to be greater than 0. I apologize. I didn't realize that if m were 0, you'd have a point. And a point of tangent to a point, not there, okay? So I'm going to go back and I'll revise it and agree with the answer key. M's got to be greater than 0. Otherwise, you wouldn't have a tangency point. All right, so that's good. I think we did okay with that. A lot of work, though, wasn't it? A little confusing, too, at times. And it's not a bad idea to consider thinking about looking at an answer key at some point. I also give a helpful diagram over here about circles, where there's some center point and these tangent lines are moving out. There's a perpendicular as well. All right, so the graph might be helpful to look at that. All right, so let me go back over here. And I'm going to get my eraser out again. And I think I did okay with that. Not a complete thought on that, but I did okay. I'm a little confused with the m at the end, but you could say m is, you could say m is equal to m. That's true for all m, but not really, because m's got to be a positive number. And furthermore, you don't want you want a point of tangency, so you need a circle. All right, let's just take a look. So 1, although tedious, I was able to do it. I was able to do 5. I'm going to do 4. I'm going to do 4 a little bit differently, though, than most students would do it. And I want to point out, what happens to a lot of students is they just simply start squaring the sides. I'm not opposed to it. All right, so that's one thing, you just square both sides, but unfortunately you get a lot of roots in it, and that might be problematic. I mean, there's a couple of different things you could do, but before I do anything, I want to tell you something. It can't hurt to look at the domain of the problem. So the left-hand side, all right, and again, the key word here is real solutions. If the left-hand side, the x minus 2 must be greater than 0. So that means x has got to be greater than 2 or equal to it. Now, if I look at the right-hand side, what would I get? I'd get 4 minus 2x. Well, 4 minus 2x must be greater than or equal to 0, or 4 is going to be greater than or equal to 2x. A little strange to say that, by the way. Or x is going to be less than or equal to 2. Well, you know what? Looking at those two things over there, if there is a solution to it, it's got to be the intersection of these two sets. And the only number that intersects these two sets is the number 2. So let me take a look at it, see if 2 works. If 2 works, it's the only possible solution. If 2 doesn't work, there is no other solution to the problem in a real number system. Let's see if 2 works. I'll write this down. X equals 2. It's the shared domain, by the way. You get 4. Well, that would be 0, right? And what do you get over there? 4. And that would be 0. So that does work. Right, so I'm going to say x equals 2 is the only real solution to that problem. Again, shared domains, the only thing that share is 2, the left and the right-hand side. And since 2 worked, it's the only solution to the problem. Now, if you want to, I mean, I'm not saying don't do it the other way, but I want to point out some of the trouble you're going to get into. And this is going to be 4. And then over here, it's plus root 4 minus 2x. Again, if you try to square both sides, and again, I'm not opposed to trying, this would be x4 plus x minus 2. Oh, I got to do this now. Plus, it would be 2x squared root x minus 2. On this side, you get 16. I think probably at this point in time, you probably are guessing that things are not going well for you. And what's that going to be? 8 root 4 minus 2x. I mean, it's getting longer and the roots are not disappearing. It just looked nightmarish. All right, and what else could you do? I don't know. You could keep trying to manipulate, but I'll be honest with you, It just doesn't look productive, all right? It looks like a tough one. And that's where a lot of students get lost. They'd square it, they try to get the terms on one side, and they'd be here all day looking at that. So it's a shared domain problem, and the only thing they shared in their domain was the number 2. And lo and behold, it's the only thing they shared. It does work. 2 does work, and just by plugging it in. Let's take a look at the key and see what they got over here. This is number 4, right? See how they did it. The domain only contains one number in common, x equals 2, so it's the only possible solution and it works. So the only solution is x equals 2. That looks pretty good. So let's go back and review what we've done so far. And we've done some of the questions, but not all of them. Right, so we're going to start to erase. And I want to remind you what we've done so far. And again, you should always be happy if you get some of the problems done. And I'm going to, I don't know, I guess I'll keep going, right? So, I don't know, that 3 is scaring me. So I'm going to try 2. All right, I'm going to try 2. So 2, I'll give it a shot. Whoops. Now I got to look at that again. What is it? X squared plus AX plus A equals 0. Well, let's read the question. What does it say? For what values of real number A does the quadratic equation have 2 real zeros? One with one of those zeros positive and one zero is negative. Well, what I'd like to do is I'd like to look for the zeros then. Now, I'm not going to factor that. I'm going to use the quadratic formula. And let's take a look at that. And by the way, I know my problem is to find out what the A is. But this is getting a little bit confusing, right? So let me just start off with the bottom would be twice the coefficient of x squared. And then the first term on top would be the opposite of the coefficient on x, which would be minus A, plus or minus. Let me write this down for you. And this is where I get some troubles over here. So it's the coefficient on the x, which would be A, but A squared, minus 4 times the coefficient on the square term, which is 1, times the constant term, which is A. So I know what my root looks like. It looks like this over here. Now for the root to be real, I'm going to simplify this a little tiny bit. For the root to be real, let me simplify this a little bit first. And I'm moving along okay, but I'm not there yet. So it's going to be A squared minus 4A. For the root to be real, A squared minus 4A would have to be greater than or equal to 0. Unfortunately, if it was equal to 0, I want to point out you'd only have one root, which would, and it would be repeated. It would be minus A over 2. So I got to get rid of the equal sign now. Again, if it were equal to 0, that root would disappear, and you'd be left off with only one root. It's repeated, but only one root. All right, and I want 2 roots. All right, so what I got to do now is figure out when does A squared minus 4A, when is it greater than 0? Well, let me write this down. A, let's see, that would be A minus 4 greater than 0. All right? So I'm going to put my little number line down to help me out with the analysis of this. And I'll put this over here. And this is tough. I'm not saying it's going to be easy. So I'm going to say A could be 0. And the other number A could be is the number 4. And I would do kind of simple test analysis. For example, a test point over here, you might say A is 5. A test point over here, you might say, what happens if A is 1? A test point over here would be A equals minus 1. Or test points on the interval. And let's just test it out and see what happens. Well, if you test the 5 out, you would get a positive times a positive, so it's a positive. Now, positive numbers are definitely greater than 0, so this would get shaded in. Now, what happens if you chose 1? You would get 1 times a negative number, and this would be negative, and negative numbers are not greater than 0. Now, let's try minus 1. Well, the first factor would be minus 1. The second factor would be minus 5. And minus 1 times minus 5 is a positive number. So that test value proves to be positive. All right, here comes where the trouble comes into play. Someone says, oh, that's the answer. It could be. It could be the answer, but I want to make sure you understand reading this thing is going to be pretty important. All right? Let me just erase this over here. I'll trace that line back in. Sorry, big eraser, right? So I got 2 different intervals to check, but I want to go back and read the question to you. So it says, for what values of the real number a does the quadratic equation have two real zeros? Well, you know what? Both of these will produce two real zeros, but what they want is they want one of the zeros to be positive and the other to be a negative. All right? So they want one of the roots to be positive, one of the roots to be negative. So what I want to do is I want to just think about it. And I want to think over here first. All right, I want to think over here first. And so if you're below the zero, all right, if you're below the zero, right, like you could take a test point if you want, like, I don't know, like minus 10, let's say, for example. Let me write this down for you. So minus 10, well, minus 10 is plus 10, right? And then what do you get? Plus or minus. Again, I'm just thinking. I want to think about something on that interval, just if I can convince myself of something. That would be 100. You get the idea? And then you'd get plus 40. All right? Now, I'm kind of looking at that, and I definitely see a positive number there. And let me see if I did that right. So a squared plus 40, that would be 100. Minus 10 is below 0, right? So 100, I got the 40, that's 140. That's definitely bigger than 10, right? So I'd have 10 plus a number bigger than 10. That's certainly positive. And I'd have 10 minus a number bigger than 10, and that would be negative. So this would give me a positive and negative solution. All right? Let's take a look at this one over here. And I'm going to take a number over here like, I don't know, maybe I should take 10 again. And let me just get my eraser out. And again, let me get this erased too. So I found over here you get a positive and the negative. And let me do the 10 now. What do you get? Minus 10 plus or minus. I got to be careful here, don't I? And what do you get there? You get 100 minus 40. Well, this would be minus 10 plus or minus a number that is going to be smaller than 10. So if it's smaller than 10, minus 10 plus a number smaller than 10 is definitely going to be negative. And minus 10 minus a number smaller than 10 is still going to be negative. So over here I'd get negative, negative. There'd be two negative answers. I don't want that. So the only solution to this problem over here is if A is less than 0. Now someone says I have a better way of doing that. I'm not saying you don't. I'm just saying it can't hurt to think through different ways of doing things. But you know what? I'm going to see if that's the right answer, all right? That's the way I thought through it. That's the way I got through it. I don't know, another day I probably thought through it a different way, but let's take a look and see what they said over here. Yeah, final answer. And they went through the analysis over here with the quadratic formula. All right, let me go back. I think I'm okay with this. Let me get my eraser out. Really wasn't that bad of a problem. It did require me to think, by the way. And there's other ways to think through problems. Don't think there's only one way to do something. And you might think one way is better than the other. Yeah, sometimes they do make judgment calls on that. One way is better than the other sometimes. More elegant, more clear, whatever, all right? Sometimes things are very thuggish. Sometimes things are very elegant. So what I'm going to do now is I'm going to talk about the next problem, the last problem I thought about, and I want to go through this over here and just read it to you. It says, you've been given a rectangle ABC0. I'm seeing the picture, by the way. And it's a helpful picture, by the way. They say this is a helpful picture. It's helpful. It's really a helpful picture, by the way. This is a helpful picture. All right, I'm going to use the picture. So it says, given a rectangle ABC0. I see it. In the figure below, figure 50 on page 212. Let's make sure it's 212, right? Yep, I'm seeing it. With OA equals to A. I'm going to write that down now. So OA, the length of that side is just A units long, all right? And it says OC is C, all right? So that side is C. So this side over here is C, and this turns out to be A. All right? So I have to be very careful. It says there's 3 concentric circles with radii OA. That's a small circle. The radii OB. Gee, I don't see that. But I can put it in. I'm going to say that's radius B. So the line segment OB is just B. I can call it B. Be consistent. And what is that? Pythagorean theorem. And what's Pythagorean theorem? It would be A squared plus C squared. Again, I'm just trying to make sense out of the picture. All right? And this radii over there is just B. All right, keep reading it. OC, well, that's C. So compute the difference between the area of the inner circle. So the area of the inner circle is going to be pi r squared. Well, the inner circle is that small circle, and the inner circle is going to have a radius of A, so it's going to be pi A squared. All right? So compute the difference between the area of the inner circle with radius OA and the area of the annulus generated by the concentric circles with radius OB and OC. So I want to talk about the annulus, right? Generated by the concentric OB and OC. So OB and OC, they're talking about this ring over here. That's what they're talking about, this ring. All right? So let's compute that ring. And what's that ring going to be? I got to be careful here. It's going to be, let's write this down. The area of this ring over here. This is the ring. That's going to be what? It's going to be the outer circle, which is pi b squared, minus the inner circle, which is going to be pi c squared. Well, let's see if I can do that. Pi b squared, let me write this over here, is just a squared plus c squared. So it's going to be, b squared would be a squared plus c squared minus pi c squared. And this is going to be pi a squared plus pi c squared minus pi c squared. And what's that going to be? Pi a squared. Now, suppose I don't even remember what they asked. They want to know what the difference between this and this is, and it's 0. All right, they have no difference. All right. So what I want to do is I want to look at the key, and I'm going to say maybe a tough read, but I got through it. I make mistakes sometimes. And we're looking at number 3, right? Yeah, 0. All right. And again, stuff's written down there, kind of terse language, but it's sufficient for students that understand what the question is to get there. All right. Now, granted, some students can say, I got a better way, and that's fine, though. And certainly, the worst thing about having a better way, everyone's got a better way, right? But sometimes there really are better ways, right? A better way there, and we should listen to each other. All right. Sometimes, teachers don't always do things the right way, and students always do them right way. It's good if we can have this conversation and come to some agreement about what might be a good way. But good way for one person may be a bad way for another one. But if you need to reach out to me and I'm able to get, to handle the emails that come in, I'll be more than happy to entertain your thoughts. Now, my email address is Bannon. That's B as in boy, the @ nnon.us. And certainly, as I say, if I'm not overwhelmed with emails, I'll try to answer you. I will try to answer you. Now, let me just remind you of what we've done here, and going back over the questions again. I'm going to say, in hindsight, probably the easiest question for me to do in hindsight was probably, let me go through this with you. I'm going to say, I think this one wasn't bad here, and also 4 wasn't bad, all right? Other ones, I'm thinking 1 wasn't that bad. Sorry about that. 2 wasn't bad, and 3 wasn't bad. I can't see any question being worse than the other here. All right? I really can't. I've seen them all like the same type of difficulty. Now, granted, 3 might have been more difficult because of the reading of it, the letters in it, the picture, whatever. By the way, if you have the electronic document, you can blow these pictures up if you like, and so forth and so on. All right? So again, please feel free to reach out to me if you need to. Thank you for paying attention, and also thank you for making some attempt to solve the problems. I do appreciate that.